We can all agree that the world we live in today is vastly different from just one generation ago. The futurist Ray Kurzweil wrote in an essay that humans today find it hard to comprehend their future. He argues that technological change today is exponential and that we won't experience 100 years of progress in the 21st century. At today's rate, it will be more than 20,000 years of progress. And in this age of technological innovation, computing power will play a significant role. Innovations in driverless cars, robotics, nanotechnology, artificial intelligence or AI and machine learning, cryptography for secure communications, and many other areas of science and technology will be powered by super-fast computers, faster by orders of magnitude. Quantum mechanics will power these next-gen computers.
Kind of problems which require exploring many possibilities and then finding the best one. A quantum computer is likely to do that problem better than a classical computer because of the fact that this superposition allows you to explore many things in parallel. And then you arrive at the answer a lot faster. I mean, this is a very simplistic picture, and that is why the possibilities are still endless.
The next obvious question is, how do quantum computers work? Conventional computers encode information as a string of binary digits, 0 and 1. In contrast, quantum computers use quantum bits or qubits. Qubits exist in a superposition state, that is until they are measured. Qubits can be both 0 and 1 at the same time. Just like the cat in Schrödinger's thought experiment can be alive or dead until it is observed. For example, let's say you're trying to figure your way out of a maze. You will rule out every possible exit one by one until you find the one that leads you out of it. By contrast, a quantum computer would check out all the escape routes simultaneously and present the right choice instantly.
Let's just build up on this idea of a bit. If you go to 2 bits, there are 4 possibilities, right? 0, 0, 0, 1, 1, 0 and 1, 1. These are the numbers 0, 1, 2 and 3 in decimal written in binary. But a 2-bit system, a classical 2-bit system, will be able to store one of these 4 possibilities. Whereas a 2-qubit quantum system will be able to be in a superposition of all the 4 possibilities at the same time.
Although quantum computers carry the immense potential for the future, they are already making their mark in some industries. In the field of medicines, quantum computers can mimic the same quantum properties as the molecule they are trying to imitate, thus paving the way for better and cheaper drugs in the future. Another area where quantum computing offers immense possibilities is cryptography and secure communications. Cryptography is the science of securing information and transforming messages through codes or texts that are hard to decipher. These codes are called keys or ciphers. When you log in for net banking, fill out an online application for a passport, or carry out any transaction on an e-commerce site, your information is protected, transforming it into an unreadable format or encrypted to prevent any misuse. Today's cryptographic systems rely on complex algorithms and the difficulty of factoring products of large prime numbers. Quantum computers, owing to quantum algorithms and enormous computing capability, can break these encrypted communications relatively easily. So once quantum computers become common, what will it take to keep our data safe? The answer lies in quantum encryption, in which security is maintained using the principles of quantum mechanics. Any attempt to break into the system invariably affects the system, alerting the legitimate parties about the eavesdropping. Countries and companies want to be the first to exploit breakthroughs in quantum mechanics to gain a competitive commercial and strategic advantage. In 2009, the global quantum computing market accounted for about $90 billion. According to some estimates, it will grow at a projected annual rate of 29% through 2026. Imagine a future where quantum sensors will be able to prevent floods by predicting weather systems, monitor the water table more accurately, and help in the discovery of oil and natural gas reserves. A future in which our telecommunications and financial infrastructure will be more robust and secure than ever before. And our cities will be able to predict demand for its infrastructure in real time and allow smarter use of energy and water resources, enabling higher environmental standards and efficiency.